Today's topic is repurposing the International Space Station using a thrust pad system with 8 new docking ports to ascend to and sustain a Paniagua Earth-Lunar Orbit. This unique orbit will be defined later in this video. The over 25-year-old ISS apparently has no current major problems that would prevent it from operating after 2030. Therefore, several space partners have considered various ideas because of the environmental hazards associated with bringing ISS back to Earth, such as attaching modules to the ISS, then eventually detaching the modules to form its own station and renting out those modules to paying customers. Reusing aspects of the station, such as melting down some of its metal or repurposing some of its modules, because the White House was receptive, and it fits with the politics of the current administration to reuse and have a circular economy. Bring either parts or modules back to Earth for display in museums. The current propulsion system on the ISS is not equipped to ascend from LEO to lunar orbit with its current thrusters that do not have enough power and sustainability to make the ascension to lunar orbit and remain there. Using efficient nuclear thermal propulsion is more practical by allowing ISS into orbit cycle time between LEO and the Moon's orbit within a 14-day time period. Therefore, every 28 days, the ISS would pass closely by the Moon. In effect, the ISS would become a taxi from the Earth to the Moon and back again. For the purposes of this video, the orbit is being referred to as the Paniagua Earth-Lunar Orbit. Ion engines can 1. Permit spacecraft to achieve higher velocities for interplanetary or interstellar flight. 2. Provide a more gentle threat continuously over periods of months and/or years. And 3. Be more cost-effective regarding liftoff because chemically launched space vehicles can be less powerful. Ranking of the 3 types of thrusters: electrothermal, electrostatic, and electromagnetic. The electrothermal thruster is the simplest because it uses thermodynamic principles of gas acceleration in nozzles. The electrostatic gridded iron thruster and the Hall thruster are proven more mature types. The electromagnetic thrusters are preferred as the propellant is accelerated in the form of quasi-neutral plasma rather than ions or electrically charged particles, and are not limited by an electric space charge as are the gridded iron and Hall thrusters. Tesla Aerospace Systems needs to design, construct, and secure to the ISS a thrust pad system and docking ports using a collar and stanchions on the main port to the ISS. AI Solutions could provide either the off-the-shelf or custom astrodynamic software to improve the functionality of the thrust pad system. Repositioning the ISS is a complex task. Tesla Aerospace Systems needs to consider how to handle the pre-launch, launch, and post-launch phases. In the pre-launch phase, appoint a project manager who forms the following committees: Finance Committee, use a public-private approach, seek funding from NASA and other stakeholders. The Design and Production Committee, use SpaceX to provide a launch rocket from Earth to LEO. Partner with Northrop Grumman to build a thrust pad system containing docking ports. Communications/Software Committee, contact AI Solutions for astrodynamic, off-the-shelf, and custom space software. Central Command Center, Launch Committee to handle both launch from Earth to LEO and post-launch phases from LEO to Earth orbit. At the initial meeting, the project manager will task each committee to meet separately, create a work timeline, create a list of necessary supplies, providing a cost estimate and prospective vendors and/or manufacturers. Test all equipment for compliance with Federal Aviation Administration, and other regulatory agencies' requirements. Use multiple SpaceX cargo shuttles carrying the payload to ISS. Some will be manned while others unmanned. Post-launch phase. After docking the shuttles, unloading the payload, and securing the thrust pad system, test all equipment prior to loading any old equipment onto the cargo shuttle for return to Earth. Once the thrust pad system has been satisfactorily tested, the remainder of the refurbishments for the tourist may be installed. New equipment will dock at the existing docks, while outgoing old equipment and refuge will leave via other docking ports. Once the thrust pad system with 8 new docking ports is operational, it will be more efficient to evacuate old and contaminated equipment and to receive new astronauts and space tourists. The primary focus of repurposing the ISS is the addition of the thrust pad system with docking ports to the ISS in order to ascend and remain in transitioning Paniagua Earth-Lunar Orbit. This accomplishment fulfills the thesis statement. Recommendations: remove research and scientific equipment as well as any contaminants. Improve sleeping, dining, exercise, and personal hygienic accommodations. Renovate the environmental control and life support system for a more breathable atmosphere. Provide spacefarer with orientation lecture and/or tour of spacecraft. Affix directional signs to the ISS walls. Provide lecture on re-entry reactions and/or experiences to tourists. Benefits are: repurposing the ISS is economically and environmentally desirable. Establishes a sustainable lunar presence to maximize economic and geopolitical potential. Continues the cooperation of various nations and the sharing of technological information